Hello, everyone. My name is Samantha. Thanks for tuning in to this Cloud Nonstop webinar on cloud native applications. Our presenter today will be Tony Vinayak, who is VP of Consulting at Cloud Nonstop. A little bit about Tony. He has been in the software industry for over 20 years with a wide variety of experiences in software tools and infrastructure space. Tony is also a certified AWS solution architect and has led several client projects for cloud transformation and DevOps automation over the years. If you have any questions during the webinar, please type them into the questions panel, and Tony will try answering as many questions as possible at the end of the webinar. At this point, I'll turn it over to Tony.
Thank you very much for the introduction, Samantha. Welcome everyone to this webinar series on cloud computing. Recently, we did a webinar on cloud migration strategies, and as part of that, we saw how companies they ease into the cloud platform, doing a very simple, perhaps a lift and shift migration to begin with, which involves moving an existing server into the cloud, and then later on getting more advanced and then rewriting or creating new cloud native applications. So this talk is going to focus more on what are these cloud native applications, what are the defining characteristics, and we will look into each one of those. A little bit about who we are as a company. So we've been around since 2012. We are part of a bigger company, Progressive Infotech. 1,200 plus employees worldwide. We've been doing cloud deployments for a while, and we are a certified partner with Amazon, Microsoft, as well as Google. And we also provide 24/7 NOC, Network Operations Center, for keeping an eye on our customers' cloud deployments. So, so moving on. So in terms of the cloud, as you would know, the way to adopt the cloud has several flavors to it, namely infrastructure, platform, function as a service, and then of course there is software as a service that we are all quite familiar with. We're not going to be focusing much upon SaaS in this particular presentation. There really isn't much to talk about that in terms of architecture anyways, because pretty much everything is taken care of for you by the vendor. And by that, what I mean is when you look at how these different services, they differ from each other. So you got the on-prem, for those of us who've been around for a long time, so we've all grown up with it, where businesses, they have to be pretty much managing the entire technology stack on their own, right from the networking and the hardware all the way up to the applications and the data, and a lot of effort that's involved in nurturing and upkeep of the on-prem stack. An easy segue into cloud is via the infrastructure as a service, which is actually the most popular way to adopt cloud, at least at the moment. And that consists of simply making use of the infrastructure layer available on the cloud. So networking, storage, servers, virtualization, so all of that is taken care of by AWS, Azure, Google, those vendors, and then you simply have to be taking care of everything that is operating system onwards. So lesser work for you as a business, and even for managing the bits that you are responsible for operating system onwards. You could engage managed service providers, and that's what we do. A little bit of a plug for who we are as a company. So we help our customers manage their infrastructure stack that lives in the cloud. Platform as a service is a higher degree of abstraction where you only have to be worrying about deploying your own applications and taking care of the data layer. And even for managing your data, cloud providers, they have several options available. So these days you have cloud native databases like Amazon Redshift for data warehousing, or Aurora, and so on and so forth. All kinds of relational databases, NoSQL databases, graph databases, and so on and so forth that are available in the cloud. So So that constitutes platform as a service. So the amount of work that you have to do is lesser, and you can be focusing more on what you need to be building. And then there is a software as a service, which is pretty much a fully hosted solution. So if you're using something like Salesforce.com as your CRM, or something like Workday for your human resources application, so you would understand, what that means. Right. So some more examples of infrastructure as a service. I'm myself more familiar with AWS, so I'm just quoting some examples for that particular framework. But obviously, there are equivalents of those that are available in pretty much all other cloud frameworks, including Azure, Google Cloud, OpenStack, and so on and so forth. So on AWS for the compute, you have what they call as EC2. For the storage layer, they provide you, things such as S3, EBS. For networking, you can be configuring your own subnets, firewalls, NATs, etc., for creating your own virtual private cloud, your own piece of real estate in the cloud, which is segregated from everything else, that goes on out there. And in terms of services, so it is an infrastructure as a service after all. So services provided include hosting, monitoring, logging, security, maintenance. So all of those services are taken care of by the cloud vendor for you. Platform as a service, some more examples, like I was mentioning early on. There's a variety of database servers that are available for you to pick and choose from. And the good thing is, things such as backups and high availability, and patching of the operating system, all of those, you need not worry about. So the vendor, in this case, Amazon or Azure, they take care of that for you. So you can just simply focus on configuring the database and using it. And likewise for data warehousing, they provide, Amazon provides Redshift. If you are into big data computing, so you would understand setting up a Hadoop cluster and the related technologies is certainly not for the faint at heart. It does require fair amount of work, or you could be using something like AWS EMR, which has it all pretty much set up for you, and lot easier for you to make use of a big data framework. And likewise, AWS also provides something called Elastic Beanstalk that makes it easier for you to deploy your applications. If you have an application written up in something like Java or a web app or a .NET application, so everything that is required in terms of provisioning, it's already there, so that all you have to do is upload your application. So those are the benefits of using platform as a service. Now, one of the newer, more recent developments has been, and it's pretty exciting, something which is coming to be known as function as a service. It is currently the highest level of abstraction in cloud computing, also known as serverless computing, only because there is no server that you need to be configuring and monitoring and ensuring that it is up at all times. So all that you're doing is creating and uploading functions. So it's a different paradigm, and so you would now be thinking in terms of breaking down the applications into smaller functions. And functions can be written in a variety of environments like Node.js, Java, Python, .NET. So all the popular runtimes, they are supported. The good thing is, excuse me, that you don't have to worry about provisioning those execution environments. So don't worry about the hardware, don't worry about the software, and you don't even worry about auto scaling, and that's huge. And what it means is, as and when the demand goes up for the function, for any one particular function, the framework would automatically scale it up horizontally and instantiate additional instances of those functions, each function running in its own environment, so that additional requests can also be effectively handled rather than there being any bottlenecking. And another good thing about the function as a service framework is that you're only paying when those functions are invoked. So if the functions are residing there and they're not being used, you're not paying anything. So which contrasts with the other options in infrastructure as a service or platform as a service, where you need to have the servers up and running, and you want to keep them up and running so that they are available as and when you need them, but you are paying for the uptime, even when they're not being used. So yeah, it's a very different costing model and a lot easier in terms of deployment. And so they're definitely gaining a lot more popularity in computing at this point of time. Now, in terms of so now we are getting towards cloud native applications, as you can probably sense. In terms of the evolution of cloud native applications, so there has been what are now come to be known as the legacy monoliths. So these would be your web applications or three-tier applications consisting of a presentation layer, a server layer, and a database. So they are now being transformed into microservices, and there's a lot of reasons why this transformation is going on. And we're going to talk a bit more about the microservices architecture in the coming slides. Likewise, the bare metal deployments and virtualized deployments are being replaced by containers, and we'll talk a bit more about what those are. Even the development methodology is evolving. So we had the waterfall, then we had the scrums, and just a bit of a play of words. Some companies, they are adopting what is known as a water scrum fall, being a hybrid of waterfall and scrum, and agile instead of agile. So some of the terms being mentioned out there as being hybrids. So they are now being replaced by continuous delivery, which is again an evolving technique, which is well meshed in DevOps, and DevOps is replacing what used to be silo development processes, and we're going to talk a bit more about what that means in the coming slides as well. And a huge cultural shift is also happening, by morphing centralized governance towards a decentralized autonomy. So, and that's huge. As you would appreciate in larger enterprises where there might be dozens of development teams all around the world. So enterprises always like to have some sort of a harmony and homogeneous development and deployment environments to reduce moving parts in the entire development and IT stack. Trying to come up with some standards for development tools. So that is now being replaced by what is being called as in decentralized autonomy, so that you have different groups using different technology stack, whatever is suitable for them for building their own microservices. So it does assume that microservices framework is being adopted. A good example of that is actually Amazon at the recently concluded reInvent event in Vegas in November 2017. Amazon actually mentioned that they have like 30 or some large number like that. I do not remember the exact number. There's a large number of technology stacks that they're using all around the world, and they're perfectly okay with it, only because they have fully embraced the microservices architecture. So we've been talking about microservices, and what does that mean? So like I mentioned, we have had the traditional monolithic approach that's been around for a long time, consisting of the presentation layer and the server-side logic and the database layer, and we are all quite familiar with that environment. And now we have the recently evolving microservices pattern, and the idea there being to split your application into smaller services, and each running in its own process, and each having its own well-defined interface, which is usually a RESTful interface, meaning typically you'll be using HTTP to communicate with those services. And you can quickly recognize the fact that splitting application into smaller components, so that's nothing new, right? service-oriented architecture, component-based development, object-oriented programming principles, all of those, they encourage building application as smaller chunks because it makes maintenance task a lot easier. It's the same thing, but now the only other major difference being that each and every component or microservice is now running in its own process. So that's something relatively new. And each one of those microservices is built around business capabilities. And the good thing is, it makes them independently deployable. And of course, you definitely want to have some automation around it while you're following the DevOps principles. And, so it's more of a, decentralized environment with minimal centralized management of those services. So this graphic, does a better job of highlighting those differences. So monolithic applications. So this box here, so each one of the shapes within the box represents some sort of a functionality of that particular application. So all of those are running in a single process. So in case you need to, for example, so one of these shapes could be the database access, the other one could be the security, and the other one could be the presentation, and the other one could be business logic, and so on and so forth. So all the various functions, that make up an application. So in case you need to scale them up, so you need to scale up the entire application, and multiple instances of the application, they need to be up and running. So you have so you're replicating the monolith on multiple servers. And as you can quite easily see, the problem there, because now we're talking in terms of replicating big chunks of code, even if the bottleneck might reside, let's say, in the database layer, because of the I/O required for handling all of the requests. Contrast that with microservices architecture or microservices pattern. So there we're talking in terms of running each one of those functions as a separate microservice. And then the benefit behind that being that as and when there's a need for scalability, so you can be scaling individual microservice now rather than having to scale up the entire monolith. A lot more efficient, and makes deployment a lot easier, and I should say development and deployment a lot easier, because now you can be developing each one of those microservices independently, upgrading them independently, deploying them independently. So makes it a lot easier to run the operations. One of the motivations behind the microservices pattern is what is known as the Conway's law. So Melvin Conway is a computer scientist, and he popularized this notion that an organization that designs a system will produce a design whose structure is a copy of the organization's communication structure. So what it really means is we've seen how in a traditional development environment, so you would have the UI or the UX team. So they are the specialists who know all about the human interface. And then you would have the middleware specialists who know how to implement the business rules behind a server. And then you have the DBAs who know all about the databases. So all the applications, regardless of what part of the business, so they would be the UI for all of the application will be built by the UI team. And likewise, the middleware specialists will be taking care of all the applications across all the businesses, and the DBAs as well. So so it is good and bad. Not so good in the sense that now there's a distinct handoff that needs to be happening between the UI team and the middleware specialists and the DBAs. And so that's where some of the nuances of the business requirements, they tend to get lost, because none of them is a business specialist. So contrasting that with the new line of thinking that suggests to build cross-functional teams, so that the teams are organized around capabilities, so that if you're building some application in payroll, so then you'll be assembling an entire team consisting of the UI and the presentation and the database and the security and the deployment. So everyone who is required for you know, developing and deploying that application would be assembled here. And they all know everything there is to know about that particular business capability. So arguably, that leads to better results. And and that's one of the presumptions of the microservices pattern. Another characteristic of microservices is polyglot persistence, which is a fancy name for each and every microservice having its own database layer. So as compared to in a monolithic architecture, so there's a monolithic database. Sure, that particular monolithic database might have partitions within it, or different tables and different views, within the database. But all of the database interaction is happening in a common database server. In a microservices architecture, each and every microservice can have its own database layer, which may be quite different from other databases. So, for example, some microservices might be using a graph database. Some might be better off using a NoSQL database, and the other ones might be using a relational database, depending upon the nature of persistence that is required by that particular microservice. So it can vary, and they have the freedom to use whatever persistence technology makes best sense for them. So it gives a lot more flexibility in terms of the technology selection. So that's another defining feature of microservices. Now, each and every microservice having its own interface, and typically you can imagine that one application might have dozens, if not hundreds, of microservices, and then each one of those has its own interface. So when it comes to usability, when it comes to developing applications around those microservices, soon it can really add up. For example, for doing an online credit card application, you need to be performing checks to verify the social security number, or verify the address, or anti-money laundering regulations, and credit check, and so on and so forth. And each one of those functions listed here may require the developer to invoke let's say 10 different microservices. So that's a lot, and it can really complicate the development work. So that's where the API gateways they help. So what they would do is they can consolidate the API call. So for example, API gateway could provide an API for SSN verification, and whatever needs to be done behind the scenes in terms of invoking different microservices, it takes care of it. It takes care of that for you, so that as far as the developer is concerned, so they could be invoking just one API call. So it makes it easier that way. And additionally, API gateways can also provide an adaptive API, so that if you're building applications that run on desktops and on mobile devices, so the rendering of the screens is going to be different across those two interfaces. So API gateways can adapt based upon the interface. So pros and cons of microservices. So small, easier to develop. The big thing is the whole motivation behind microservices is that they can be developed and deployed independently. So that's what is really driving the this particular framework. Improved fault isolation, because now you are down to individual microservice level. No long-term commitment to technology stack, because you can change it at the microservice level. On the flip side, there are now more moving parts. So, and each and every microservice is running in its own process. So that can lead to increased memory consumption. Testing is more difficult, because now it is testing across multiple microservices, and of course the need to implement inter-service communication. So in case you need to propagate some information across multiple microservices, like a client ID or something else, so then you need to devise some ways to carry that information across multiple microservices, like a token, or plus of course you have to be implementing the something like an HTTP interface to be communicating across all of those microservices. And yeah, deployment becomes more complex, because there are greater moving parts. But then again, the argument is that the pros, they outweigh the cons, and microservices does provide a better way for building your applications. Here's an example, in terms of how to piece it all together. So here you have the microservices, which are indicated here. So there is one for account services, there's another one for inventory, and another one for shipping service. And each one of those is, it has a RESTful API, that is available for it, and that's the one that will be invoked by the application. So if you're building a browser application, so you could be having some sort of a web app which is invoking these APIs directly, as an example. And here is an example of a mobile app invoking an API gateway instead, rather than invoking the services directly. Just to illustrate that API gateway is an option that is available, and you don't have to use it, but probably makes more sense to use it. And then you have separate persistence layer for each one of those microservices, which is being depicted here. In terms of adoption of microservices, most of the technologically progressive companies, they're already using it. AWS, Netflix, they're probably the pioneers, and they're all in on microservices. And likewise Uber, eBay, and several more. So they're definitely paving the way for other companies to follow by going all in on using microservices. Okay, so that was enough about microservices. Now the other important thing that needs to be called out when it comes to cloud computing and cloud native applications is the DevOps tool chain. Why? Because cloud makes it a lot easier for adopting DevOps principles on the cloud, and that includes everything from designing all the way till deployment and operation. So one of the important components of DevOps is, going back to the previous slide here, is the one about deployment. And this is where lately the Docker and the containerization has taken hold and has become fairly popular. And containerization and Dockers, it's all about shipping the code faster. That's it. So that's the driving motivation behind it. And here is the the definition of Docker and what it is. So that's lifted straight from Docker.com website. And but I just wanted to highlight the fact that it's all about shipping the code faster. So that's what it's all about. And to depict it visually, so in terms of VMs, we all know that you have the hardware, and then you have the VM hypervisor, and then in case you need to be running multiple VMs on the same server, so you would be instantiating guest OS within each and every VM, right? So you have the Linux or the Windows or whatever OS that you want to virtualize, and then you have the binaries and the application and so on and so forth on top of that. So one server could have multiple copies of operating system running on it in case you choose to deploy multiple VMs on that particular box. Docker takes a different route, and what they do is there is only one copy of the host operating system on that box, and then the Docker software runs on top of that, and that shares the kernel of the host operating system with each and every container. So it's more efficient in terms of deployment as well as packaging, so that when it comes to packaging up your application, you simply have to worry about the application and the accompanying binaries and the libraries. And you don't have to worry about bundling the operating system along with the application. So makes packaging of the application a lot simpler. So that's a major difference between containers and VMs. And the other bit of software that accompanies the containers, excuse me, is the container orchestration layer. And why? Because containers makes it super easy for deploying applications or deploying microservices on the cloud typically. And then one of the benefits of microservices is makes it super easy to horizontally scale them up. So in any particular microservice that is under excessive user load can be scaled horizontally. So all of the requirement for provisioning containers and scaling the containers and handling any container failure and so on and so forth is handled by container orchestration software. And the more popular one, and there are plenty of those out in the market. Apache Mesos, Docker provides Docker Swarm and Docker Compose. Amazon had its own container orchestration software called ECS. Recently, they also introduced Amazon EKS, which is a native support for Kubernetes, which is probably the more popular open source container orchestration software in the market at the moment. Amazon also introduced something called Fargate, which further abstracts the use of container orchestration. So a lot of options in the market at this point of time. But yeah, probably Kubernetes is the one that seems to be more popular than the other ones. So yeah, cloud and DevOps, made for each other. For example, at AWS, they provide built-in tooling for different parts of the DevOps automation. For CI/CD, continuous integration, continuous development, deployment, they provide code pipeline, code build, code deploy, code star. For container orchestration, like I mentioned early on, they provide ECS, EKS, Fargate. For infrastructure as a code, we haven't talked much about that, but basically, this automates the deployment of any application, any server. You can create templates around it in the form of CloudFormation, OpsWork. So these are the tools provided by AWS. So out in the field, you also have a lot of other tools available like Chef and Puppet, which are probably the more popular ones. And likewise for monitoring, versioning, code commit, which is based around Git. So these are the tools which are built in AWS. And likewise, other cloud providers provide their own set of tools for facilitating DevOps automation in the cloud. So we've covered a lot of ground, and we have gone through it very, very fast in the interest of time. To conclude, to sum up, how do you define cloud native applications? So we would say those are the ones that use cloud-based infrastructure and platforms. So we're talking in terms of EC2 instances and containers and so on and so forth. The applications are built using microservices pattern that we talked about and typically deployed behind API gateways, deployed as containers and managed using container orchestration software. And that's where typically we're talking in terms of Docker as containers and Kubernetes as the container orchestration software. So it just makes it a lot easier to develop and deploy the applications. And of course, it's all about developing and deploying the applications independently by applying DevOps automation techniques, only because cloud makes DevOps automation super easy in the cloud. So I think we are almost out of time now. So thank you very much for attending the webinar. Hopefully that gives you a high-level view of what the cloud native applications are all about. I think we have time for just taking a couple of questions. Let me check. Let me have a look at the question panel. Joyce asks, who are the dominant players in containerization of application packaging and deployment? Joyce, so like I mentioned early on, there are several vendors in that space. If we were to go back a couple of slides here, there it is. So the major player in the market right now is certainly Kubernetes. So it's an open source project that was originally developed by Google. It's getting a lot of backing in the market right now by a lot of vendors. Like I mentioned recently, Amazon, they also announced a native support for Kubernetes in the AWS framework. And likewise, Azure also has support for Kubernetes in their framework. So yeah, and in terms of containerization, it is definitely Docker. So they are the ones that are leading the market share at this point in time. So you cannot go wrong by adopting Docker and Kubernetes when it comes to containerization and application packaging and deployment. One more question from Ron. Ron says, regarding DevOps, you mentioned several examples on AWS. How well does Azure support DevOps in the cloud? Yeah, that's a good question. All my examples, like the ones mentioned here, they are based around AWS only because I'm myself more familiar with AWS. But Azure has been coming up very, very quickly, and they also provide a fairly fulsome suite of tools for DevOps. The big one I would say is they have Visual Studio Team Services. So that's a fairly well integrated set of services and tools. And much of the Microsoft shops, they are already using it as part of so Visual Studio as an IDE, and they have Team Foundation Server for their versioning and work items for defect tracking and so on and so forth. So the whole tool chain that exists in the Microsoft world. So that's all of that is available on Azure. And additionally, they also support open source tools like Kubernetes as part of their DevOps automation. All right, so I'm being told that's all the time we have for the webinar. So thank you very much, everyone. And hope you enjoyed the presentation and got something out of it. Bye now.